Alright, now in this video I'm going to go over how to program a night for the chess set. I've had a lot of students ask me about this. We're creating chess sets, but how do we do the night? So the way I like to do it is a combination of lathe and mill programming. So this video I'm going to show you how to combine the two. The important note to know is that we're going to maintain a center of the part as our origin, meaning the X0 on the lathe will become the same Z0 when we transfer over to the mill, which will be center of the part, so that we can flip this thing 180 degrees in the mill. Now, we're going to use a 4th axis mill for the milling here at CC, but anyone else doing this, any way to flip this part 180 degrees in the mill will work. So if you have a 4th axis, that'll work. If you just have a 5C collet block that you can flip, if not, you can just square up a block and put a 1-inch hole and use a set screw in the side of it, and that'll work as well. Just any way to hold this round part in a vise and then flip it 180 degrees for the turn. So to get started with our video, the first thing I'm going to do is I'm going to rotate this part into lathe position to get started. So to do that, I want to find the center of the part, top of the head, to get started. So I'm going to go ahead and just create a bounding box, wireframe, bounding box. Now you can create this bounding box into a cylinder or into a square, it doesn't matter, as long as you can get the true center of the part. Now I've had struggles with the Mastercam and creating the cylinder. I'm not quite sure if it's a bug. I can show you here if I put it in the Z-axis. And then I put it in a top view, you can see that my cylinder is off. It's not quite in line in X, and I'm not sure why, but if I change it back to a rectangle, then it makes it correctly. So I'm going to go ahead and just make mine as a rectangle. If it works for you as a cylinder, then great. It gets the same result at the end. So I create my cylinder, and now if I just draw a line from corner to corner, the midpoint of that line will be the center point of my night. And that's the point I'm really looking for. So with that point found, I need to now rotate this part to how I want to look at it when it's going to be in lathe position. So it doesn't matter where I click right now, I'm just rotating. I'm going to go 90 degrees this way. And then I actually like to get the head or the knight so that he's looking down instead of up. So I'm just going to go 180 degrees this way. Green check that. Now when I put it in the top view, you should see the knight in what I would call lathe position as I'm getting ready to turn it. So now I want to line up my origin here that I created from my bounding box onto my origin, my top origin, the original origin for the Mastercam, or the gnomon, I guess you'd call it. Transform, dynamic, and selection. Select the midpoint of my line. Move it over to my standard gnomon, green check. Put that in a top view. Now I can set up my plane and get ready to start doing my turning tool pass. Now I have not sized this knight at all for the finished size that it's going to be. I'm actually going to create my stock model first with the 1-inch diameter stock, and then I'll size my knight so that it fits in it. So before I create my lathe machine, I need to go to planes, come down to my planes, create my plus D plus Z, activate my plus D plus Z for my grid, my work coordinate system, construction plane, tool plane. Now I can go to machine, lathe, default. Now if I go to my tool pass, you'll see there's a machine here. When I go to my stock setup, under properties, I'm going to tell it 1-inch diameter stock and 5 inches long. I'll green check that. Now under my chuck jaws, under the properties, I need to move over to the parameters tab. This is a new position in 2021 compared to 2020. So go to my parameters tab. I can tell it 1 inch diameter stock and a Z position of -4 inches. And when I green check that, now you can see part of the chuck jaws here, and you can see that this night is huge right now compared to what I want it to be. So now I just need to scale it down to position. So if I go transform scale, grab the entire night, I'm going to turn my auto center will be on. I'm going to turn it off. And then I'm going to scale it to a factor of 0.25. So if you see I'm at 0.25 here, then the actual night fits within my stock boundaries. So we'll green check that. Now that should be a good position for the night. Everything's perfectly on center. I'm scaled to the right size. You may want to make your night a little longer. It depends on how big you made your other chess pieces. To do that, you're just going to go scale, grab the night, and I'm going to scale by axis. So I'm only going to scale the x-axis. I'm going to leave the y and the z alone. So you can see that kind of stretches my night out and makes them a little taller, which is perfectly fine to do. So I'm going to scale him out 1.5 inches taller, or 1.5% of his normal size. Green check. Now my knight's ready to go and be machined. Now when we're programming for a lathe, we don't typically program an actual model like this. We just need the wireframe for programming. So to create the wireframe from this knight of the outer extents, what I would use in a lathe, I'm going to first create a new level, level 4, and I'm going to make sure it's active. Now when I go to my wireframe, I can do a turn profile. Select my knight, end selection, and it's actually going to create, when I green check it, the outer extent of what's being programmed for the knight so that it'll all fit into a round part. So you can see that it created the wireframe, and this sticks out a little because if this knight was to spin around in a symmetrical fashion, this nose would stick out on the top. Well, because I put it on its own level, I can now turn off the other levels, and now you can see this is what it would look like if I was to run this knight 100% lathe. Well, this needs a little bit of cleaning up. I don't like to have anything out here in front, below the highest point in Z when it comes to Z0. So what I'm going to do is delete all of these lines. You can just highlight and push the delete key on the keyboard. I'm actually going to delete this one too. And then I'm just going to draw a line from here down to my gnomon. Okay, I'm also going to draw an extension line back here. I'm going to draw 1.25, an extra 1.25 inches to make this part. And what that'll do I'll give myself extra holding stocks when I transfer from the lathe to the mill. I have something that I can put in my fixture block or my 5C collet or my 4th axis to clamp onto. And then I always like to draw my line up past the stock so that it knows how much it's going to be roughing. And from there, we should be good to go to start programming this part. Now, sometimes doing that turn profile, it'll leave some little gaps in here. If we find one, it'll show it to us when we're making the chain, and we'll have to go back and fix those gaps. So I'll show you if that happens. So if I go to my toolpath now, turning, my first toolpath is always a facing. I'm going to use my custom library in here. You guys don't have to, you can use your own, but this Mastercam tool library is one that I've created, and I have the lathes here at our college set up with these tools already. So tool 1 is my CNMG. I'm going to use this tool to do my facing. I'm going to slow my feed rate down on that face to more of a finished feed rate and change my maximum RPM to 2200. And then I shouldn't have to touch my face parameters. It just defaults to facing right to 0. And you'll see there the tool came in, ran its face pass. Now my roughing toolpath, it's asking me to select the chain. And I'm going to select the first line, reverse it to the proper direction, and now I want to go select the very last line of my chain, which is this little line sticking up. And it looks like that all connected, and everything's going to work out well. If this was to have stopped and not connected, that means there's a line or something in here that doesn't connect. You need to go back and fix that line. It will not work if you create multiple chains. So I'm going to green check that. I'm going to use my tool 3, which for me is a VNMG insert. It'll get down in this detail a lot better. Change my max spindle speed to 2200 RPM. Under my rough parameters, I'm going to change it to a 60 thou depth of cut, which is a 30 thou actual radial depth of cut on the lathe, 60 thousandths diameter cut. Leaving 10 thousandths stock allowance. My lead in lead outs, because of all this extra detail, I don't want extra lead ins that are going to possibly violate stock, so I'm going to lead in straight down and lead out straight up. And then my plunge parameters, I want to make sure I can get in everywhere, so I'm going to change it to my plunge parameters that allow me to get into all those little details. Green check. And then you see that that tool is getting down in here and doing everything that it can cut. Now I'm going to make my finish tool path. All right, when it asks me for my chain, since I'm using the same chain as the last one, I can come down here and use this last button. It'll automatically select the chain from the last tool path. Same tool. I'm going to slow that feed rate down for a finish pass of 4 thousandths inches per rev. Max spindle speed of 2200. Finish parameters. We're going to go to my lead in lead outs. I'm actually going to lead in on an angle and lead out on an angle. Oops. And I forgot to do my plunge parameters. I'll go back in, change my plunge parameters, so I'll go into all the detail, green check. And since it's dirty, I have to regenerate. Good, so there's my finish tool path. Now I just got to do my cutoff. On my cutoff, I'm going to go ahead and actually make a groove back here so I can see where the chess piece is going to eventually be finished. And then I'm going to go ahead and do a cutoff that cuts the part off in the lathe, an actual parting. So I'm going to go to my cutoff. It's going to ask me to select the point. I'm going to select this point first. This will be the actual end of the chess piece. Select tool from library. We're going to go to our tool 4, which is our cutoff tool. Everything's set here. I'm going to change my maximum spindle speed, 2200. Under my cutoff parameters, I'm actually going to put a chamfer on here of 20 thousandths. Now I'm going to get rid of these radiuses so that it just puts the 20 thousandths chamfer. But to do that, because I have a true cutoff tool and it doesn't like doing any kind of side cutting, I'm going to go ahead and add a clearance cut into there first. So I'm going to change my Z increment to 10 thousandths. Okay, and then so that I don't cut this tool off completely, I just put a notch in the back. I'm going to use an X tangent point of 0.5, which will cut it down to a 1/2 inch diameter. So now you can see it cut my little clearance cut, and then it cut my chamfer on the part. And this is what my part will look like all said and done. Now we'll do a cutoff to actually cut the part off in the machine. So we're going to create another cutoff program, and we'll select actually the last point in the program this time. And without going in and changing any of the parameters, it's actually going to cut it right to 0 this time. So then you'll see the tool, the part falls away. So that's my lathe. We'll go ahead and take a look at this, and we'll see what it looks like in the simulator. And it's not going to look like a knight at this point, but that's okay. It is, we're on the right path here. So slow it down just a little bit facing, turning, finish turning. So let's put in stop conditions so that we can actually see it before it cuts off. Facing, rough turning, finish turning. There's my first notch cut off. And then my final cutoff. Okay, so now the tool will be, or the part will be ready to take over to the mill. So for Mastercam, as far as we're concerned, we're just going to create a new machine that is milling. And I'm going to go to my levels and turn my actual night back on. So to create that new mill for machining, first of all, I'm going to go to my planes and I'm going to activate my top plane back on because I don't want to use my plus D plus Z plane for my mill. So turn my top plane back on. Then I'm going to go to Machine, Mill Default. And when I come down to my toolpath plane, you'll see I have a mill now down here. We still have our lathe up top. Now we're going to be doing milling toolpaths. I'm going to go to my stock setup. I'm going to set up a cylinder, 1-inch diameter by 4 inches long. Now this stock setup is only for visual. We're going to actually create a stock model here in a minute that'll use what I've turned in the lathe for my milling so that it doesn't cut a bunch of air cuts. So in my X position will be minus 4 inches. Green check. Oops. We're going to go back into there and we're going to push the display button. So we'll see our round cylinder now for our milling. Now our first toolpath that we're going to create is a stock model based on what the lathe did. So if I go to my stock model, and you can name it if you want, I'm just going to leave it called 1. I'm going to create that same cylinder again. X-axis, 1-inch diameter, 4 inches long at a position of minus 4 inches in the X-axis. Now my source operations, I'm going to use everything, so I'm holding the shift key down, 1 through 5, everything that I did in the lathe. And then as I green check that, it's now going to calculate a stock model that'll be what you see here. This is what I just cut in the lathe. So now we have this stock model as a visual aid and as a source for programming to rough and finish this night. So, and you can turn this stock model on and off as if it was a toolpath. So let's grab everything. Let's turn all these lathe toolpaths off. Now we can start our mill programming. So looking at this part and looking at that stock model, what I'm going to do is I'm going to go ahead and program it or start roughing with a 1/2-inch end mill. But before I start my roughing, I want to create a boundary of where I want to use my milling toolpaths and where I want to stay out of for my lathe. So if you look at all this back here, this is all good, nice, finished turn surfaces that's symmetrical. So I don't want my milling cutters to go back in here and to do any extra milling. So I'm going to wireframe rectangle, and I'm just going to create a rectangle right around here, and I'm going to say this is the area that I want to mill. So this is what I'm going to use as my containment boundary. So now, as we go to toolpaths, I'm going to use an Opti-Rough toolpath. And for this style of roughing, I actually like to area mill better than the dynamic. So I'm going to change it to area roughing. The model geometry, I'm just going to select the entire model. And then I'm going to change the stock allowance to 10 thousandths. I'm just going to rough it down to 10 thousandths. Toolpath control, this is where I'm going to select that containment boundary so that my tools don't go over here and cut this nice turned surface. My tool, we're going to grab a 1/4-inch flat end mill. So we'll go to filter, none, select my flat end mill, and then we'll look for 1/4-inch flat. I'm just going to go ahead and make tool 1. I normally calculate with surface footage, but I know I'm going to be maxing my machine out, so I'm just going to put my spindle at 5,000 RPM, and I'm going to use a 1% chip load, so it's 2.5 thousandths, and I'm going to make my plunge and retract the same. Under my stock, I want to rest machine, so I don't want to machine everything. I just want to machine what this other operation left. And for the other operation, I'm going to go ahead and select my stock model. So that's selected as my source operation. My cut parameters, I'm only going to take a 20,000 step down. 45% step over is fine. Under my steep shallow, I only want to go far enough below this part to where my ball has clearance when it does my finish cutting. And I'm going to use a 3/16 ball cutter. So that's a 3/32 is my extra clearance that I need. So I'm going to detect limits, and I don't want to go the 479 deep. I want to go to 0 minus the extra clearance I need. So I'm going to go 100 thousandths past 0. So minus 0.1. Under my linking parameters, I don't need to be retracting up to 2 inches, so we're just going to retract 3/4 of an inch above the part. And then some of these 25 thousandths and 75 thousandths, these are some pretty big arc moves for this small of a part, so I'm actually going to change them to 10 thousandths. And if you don't change these, it's still fine. You'll still get good cuts. I like to make them a little bit smaller. I don't have as much extra moves going on when I'm machining. So, and then we come down to coolant. I'm going to turn my coolant on. And then if you don't have high-speed machining and you're actually using machine, you may want to change some of these miscellaneous values for the G187. But if you're using high-speed machining, you don't have to worry about it. If you're using the Haas default machine, they won't even pop up. But I just wanted to note that sometimes when I have a Haas post, I'll actually go in and change those. But we'll green check that, and we'll see. It'll take a minute to calculate here what our first roughing toolpath looks like. Okay, so that's not too bad of a toolpath. You'll notice in this toolpath, looking at it, that it's rounded like that. That's because it's actually looking at that stock model that we created from before, and not just looking at like a big square block or a big round block. So we can turn that toolpath off. Now I'm going to re-rough it with an 1/8 inch flat end mill, which is going to get down into some of these cracks and areas that the 1/4 inch couldn't get down into. So that I don't have to restart over on everything, I'm just going to take this toolpath, I'm going to copy, and I'm going to paste. The toolpath 8, I'm going to go into parameters. I'm going to go to the tool, and I'm going to create a new tool, or grab an 1/8 inch flat end mill. It's going to be tool 2. Same feed, or same speed, 5,000, but for my chip load, 1% of my diameter is going to go down to 24 inches a minute. Under the stock, instead of using previous operations, I'm actually going to go and I'm going to tell it a roughing tool. I'm going to tell it, hey, I've already gone in here with a 1/4 inch flat cutter, and I'll even let it overlap 10 thousandths. And then it'll look for what does a 1/4 inch cutter cut and what can I cut now. So the step down is at 12. We're going to put it at 10. This tool might be sticking out a little long for what it's doing. 45% step over is good. Steep shallow is good. We're going to go to that same 100 thousandths below the part. And then we're going to go ahead and green check. Now this is going to calculate a roughing program that's going to go dig out where that extra stock is. So some of these programs that do a little bit of extra calculating, they take a little longer. If you're ever wondering, is it doing anything? Oh, I have to generate dirty because I copied it. If you're ever wondering, is it doing anything? You look for this little green part here. That means it's calculating. And if you want to see what it's actually doing, you can go to the view and you can turn on the multi-threading. And then it'll give you a little window that'll show you what it's actually cutting. And you can see that progress bar right there. So that one's done. And if I look at it, we can see that 1/8 inch said, hey, we got an extra stock here, right underneath his chin, a little bit on the back here that still needed to be cut from what the 1/4 inch couldn't get. And that's exactly what we were looking for. Let's just dig it out a little more before we run our ball cutter. Now that it's roughed out, we're going to go ahead and make a tool path. I'm going to use a 3/16 ball cutter to cut this. So tool path, we're going to go to our finished tool paths, and I'm going to run a hybrid. So our geometry, we're going to select the entire part again. Stock allowance will be switched to 0. You go under toolpath control, we'll select our bounding chain. Our tool, we're going to go to the tool library, filter, none, and then we'll click the ball. I'm going to select the 3/16 ball, which is a 187 ball. I like to rough one size smaller than I'm going to finish. So I rough to an 1/8 inch flat. Now I can finish with 3/16 ball, and I know that it's not going to crash into corners and do a lot of chattering. So 3/16 ball cutter. It's going to be tool number 3. We're going to run at 5,500 RPM. And we're going to run it at 35 inches a minute. Okay, I'm not going to worry about stock undercut parameters. I'm only going to take a 4,000 step over with this tool. And a 4,000 step down. And instead of one-way cutting, I'm going to zigzag. In my steep shallows, same thing. I don't want to go past, I only want to go just the radius of the tool just past halfway. So it's an extra 93 thousandths. So my maximum depth of cut, I'm going to go 95 thousandths deep with. So we roughed it to 100 thousandths deep. I'm only going to go 95 on here, so the tip of my ball shouldn't touch any of that extra stock on the bottom. Under my linking parameters, same thing. I only need to be 3/4 inch rapid absolute above the part, and then I'm going to change these values to 10 thousandths again. I just don't need all these huge arc moves for this little tiny part. And then we'll make sure we turn our coolant on. And we'll green check that. Now this is going to finish the part and it's going to make it look pretty good. Although we did rough it with an 1/8 inch flat, and there's some areas where that rough tool will get into that this 3/16 ball cannot get into. And therefore we're going to want to do one remachine. And I'm going to remachine it with a 1/16 ball cutter. And it's going to dig out the rest of those little areas, and it's going to make this part look pretty sharp. So if I go to my view and I look at my multi-threading, oh, nope, toolpath's done. Don't need to look at that. And you can see it just went to the halfway point. Got down there. This tool, this should make this knight look pretty good. So now if we go ahead and we run a pencil with a 60 thousandths ball, that will really sharpen this up. So toolpath, pencil. We're going to select all the model geometry. Stock allowance of 0. Toolpath control. That same area that we selected for the other ones. For my tool, select tool from library, a 1/16 ball. Tool number 4, 5500 RPM. Our machines max out at 6. I usually don't like to run them at max, so I'm running at 5500. I'm only go 15 inches a minute. Now, this 16th ball is not a straight tool. These 16th balls have an 1/8 inch or larger shank. So what I'm going to do, just so that my shank isn't violating, is I'm going to go in and I'm just going to modify this tool a little bit. So my cut length on these is usually only about 200 thousandths. So my shoulder diameter is 1/8 of an inch. And my shank diameter is 1/8 of an inch. So, and usually there's a little taper on there. Mastercam's not letting me select the taper. What we have here, though, is a better representation of what's actually going into the machine. So by drawing this 1/8 inch shank on here, it'll make it so that this coming straight down along these walls does not violate into the part. So as long as your 1/16 ball has 200 thousandths of cut before it starts tapering up, you should be good with this tool. So under the stock portion, we're going to do the same thing. We're going to use a roughing tool of a 0.1875 ball cutter. So 0.1875 divided by 2. Okay, we'll give it an 8 thousandths overlap, which is going to be roughly 2 passes because I'm only going to take a 4,000 step over. And then my maximum number of offsets, I'm going to uncheck that. I don't want to tell it how many offsets. I want Mastercam to figure that out for me. So if I just uncheck it, it'll do that. My steep, shallow, detect limits. I do not want this ball cutter going further than halfway on the part. So minus 0.035 will get me just past the center of the part. Linking parameters again, 0.75 absolute. Change all these to 10 thousandths. And then I'm going to turn my coolant on. Now this one's calculating. These pencil paths take a little longer to calculate. Maybe we'll actually get to see our multi-threading here. So we turn that on and we can see a little bit of the progress. That's to calculate these extra offsets. So this might take a minute or so. But now that I have, this will be my last tool path. Then we'll take a look at what half of this part looks like. And then the second part, half of the part programming, is actually very simple because we're going to create a new plane 180 degrees opposite of this. And then we're going to go ahead and copy and paste these programs. Now, if you have an actual machine with an A-axis, it'll run this all as one program, and then it'll just rotate the A-axis 180 degrees and keep running. If you do not have that, you're going to want to post this out as 2 separate programs. So you can post 7 through 10 as a program, and then you'll post 11 through 13 or 11 through 14, the final 4 tools as another program, and you'll actually physically rotate the part 180 degrees in your fixture. Okay, so now that this is finished, we can see that 1/16 ball went in there and really detailed out some of this stuff to make it look a lot better. So now we'll select all of these operations, turn them on, and actually, you know what? Let's select everything that we've programmed so far, lathe and mill, turn it on, and then let's go check and see what it looks like before we get our next part programmed. And so far, not too bad. It says we got about 45 minutes into this. So if we look at the lathe, we seen this earlier. Ooh, and our part disappeared. Nope, I have to go fix this so we're not cutting that part off. 1 second. Let's try this again. Okay, so it's got the groove. I just unselected the cutoff so that we don't see it happening. So now we're going to do that rough mill with the 1/4 inch flat. Looks good. Here comes the 1/8 inch to dig out the extra stock. Looks good. The 3/16 ball. And you can see as it cuts right up here, you're not seeing a whole lot happen because a lot of that was turned on the lathe already. And as this 3/16 ball cuts, you notice some of these marks left over from the 1/4 inch flat and the 1/8 inch flat. That's okay because our 1/16 ball should come in here and clean up all of that. And that's why we ran that 1/16 ball. Speed this up a little bit. The night's looking pretty good. And now this last tool path is a 16th ball, and it's just going to come through, and you can see that 1/8 inch shank on there, and just going to clean up everything else that it can. So this night, for being halfway, is looking pretty decent. Now, for the other side, what we have to do is first create a plane. And I'm going to create a new plane based on the top. So we're going to plus dynamic. And I'm going to place this plane on our top plane. And I'm going to go ahead and just rotate it 180 degrees. And I'm going to name it 180. Now you see I have this 180 plane. Well, I don't need to activate it. All I need to do is go into toolpaths, and I need to take 7 through 10. So I'm holding the shift key down. I'm going to right click and copy, and then right click and paste. So now if I go to toolpath 11, which is my new toolpath, and I go into the parameters, I can come to the planes tab. And I'm going to change these to the 180 plane. So if I select this little button here, I can scroll down and I can see 180. Green check. And I'm going to push the over arrow so that my WCS, my tool plane, and construction plane are all the same. And I'm going to continue to do that through all the 4 new toolpaths. So toolpath 11, parameters for tool 12, plane, 180, over, parameters, planes, 180, over arrow, and then one more toolpath, parameters. Okay, so now that this is done, I should have all the toolpaths coming from the back side as well as the front side. And that should be everything to program this part. So let's take one last look at it in the graphics to make sure that everything looks good, and then you should be ready to post out your programs and run. I'm going to select all operations. I'm going to push the control button and then unselect my cutoff for the lathe. Go to my verify. I'm going to turn off my stop conditions, and I'm just going to let it run. So so right now it's got it at about an hour and 28 minutes. It seems like a long time, but if you're making a chess set, you're only making 4 nights. So that's really not too bad. A couple class periods, and you'll have some really cool looking knights to go with your chess set. So you can see the operation 1 finished on, and then here we're cutting the other side. Finishing with the 3/16 ball. And we're going to go ahead and go into the pencil trace. And that is a pretty sweet looking knight done on lathe and mill in Mastercam. So I'm pretty happy with it. Go ahead and yeah, watch this video over and over until you guys get it done. And I look forward to seeing your knights programmed and cut in aluminum. All right, thanks for watching this video. We'll see you on the next one.